Hello, Sloohers, and welcome to Slooh's Practical Astronomy series with me, Paul Cox, where we can learn to explore space together and get the most out of our Slooh memberships. I often say this, but I know I work for Slooh, but front and foremost, I'm a Slooh member. I really love using our telescopes, and I do every single night. But anyway, now, if you're somewhere on the Slooh website and you're suddenly hearing my voice and don't particularly want to, then you can just turn off the little audio bug up here. There's a little switch up here, or you can change the volume of it as well if you want. But I'm going to be screen sharing a few little things. So if you want to follow along with what I'm doing, then just left-hand navigation, go to live cast, go up to space situation room, and this is where you can watch me screen sharing and anything else I'm talking about. Now then, Messier Marathon. Were you watching my Slooh members Messier Marathon 2018? You can basically put all of those words in whatever order and it kind of makes the same amount of sense. But anyway, it's Slooh's Messier Marathon. I did a live cast just over the last hour. Now, if you got cut off and you missed the end of that, don't worry, because we saw that happen, but we continued recording, so you can watch the end little bit where I covered the other object types that we're going to see of our 110 objects on that night. So if you missed that, don't worry, you can watch that like all of Slooh's livecasts. Again, just hop over to livecasts in the left-hand nav and go to browse livecasts, and there you can see, in fact, look, we could watch it together right now. So you just click on that and off you go. So although you got cut off if you were looking at the on the website, the last little bit of it, which is always the best. You always tell your viewers that the bit that they missed was the best part of the show. Anyway, you can just catch up with the end of that. And the biggest point I was making there actually is next week, on Sunday the 11th, we are going to be talking in our countdown to Slooh's Messier Marathon show. We're going to be talking about the mechanics of how to set up your missions for it, how we're going to decide who books missions for which objects and when they're going to do that and stuff like that. So that's what we're going to deal with next week. And then on the night, of course, we're going to go into all sorts of detail. We did cover a bit of it in that last show, but we're going to go into lots more detail about the various objects that we're going to see. I'm going to be up all night on the night of the 17th, so hopefully you'll be able to join me. It's why we do it on a Saturday night. But anyway, all right, what else have we got tonight? Well, we have got the second week in a row with no Helen Avery and her constellation stories. What's that about, Helen? No, Helen's actually been very busy. She's been travelling, which is why she hasn't managed to join us for a couple of weeks. But Helen's going to be back next week, I understand, with more of her mythology whilst looking at the live telescope views. So that'll be quite good. Anyway, what else are we going to look at tonight? Well, let's have a look. See our telescopes. Well, Chili's online. Let's take a quick peek at Chile. Oh, hello, Jerry. There's a new member I haven't spotted before. Jerry is an apprentice member. And what are you looking at? Bennett 25A. So, we've been talking about catalogues a lot lately, haven't we? And the Bennett catalogue. I think it was Keith Smith or Dave Larkin turned me on to the Bennett catalogue. I think it was Keith, actually. So we were talking about the Messier Marathon. Oh, look at this. Oh, this is one of our favourite ever Southern Hemisphere objects. This, by the way, this actual object, we've been doing a lot of work at the moment about objects' actual sizes and conveying that to you in the live missions. But this is the Tarantula Nebulae, and its real size is massive. But anyway, we were talking about that last mission. And we were talking about the upcoming Messier Marathon, where we're looking at the 110 best objects. But Messier, of course, was a Northern Hemisphere observer. So you then had Sir Patrick Moore come up with the Caldwell catalogue, but Keith told us about the Bennett catalogue, and the Bennett catalogue is apparently some of the best objects that are missed off those other catalogues in the Southern Hemisphere. So brilliant for this. But look, this is sublime. Conditions are looking good. The moon won't be up yet, and I'm going to actually sometimes these nebula look better in grayscale than they do in colour. Let's have a look at the wide field view of this. Look at that. You start seeing that, you know, this field. Let's switch off the telescope portal, and this little lot down here, look, there's a huge cluster of stars over here, but a lot of this looks like more nebulosity, extending well beyond the Tarantula Nebula. And in my last show about the Messier Marathon, we were talking about emission nebula, where the gas and dust clouds are so excited by usually the high energy ultraviolet energy coming from nearby O-type stars a lot of the time. And it excites the gas so much that it strips electrons and it starts emitting light, an emission nebula, rather than a reflection nebula where the light is, you've guessed it, just bouncing off, reflecting off the dust and gas. But anyway, if you missed that other show, go back to that. I'm going to snap out an ultra wide field there as well, because actually I don't think I've got many of these in my pics. Anyway, I was going to say we were going to look at the telescopes. Let's have a look at the all sky, because one of the things I did want to cover tonight was checking conditions, because I don't know if you spotted it, but earlier on this evening we were able to open the Canary Islands Observatory. Unfortunately not for very long. So actually, you know, we haven't gone through these bars, have we, in any detail? Let me just check that you can see it. You can. So let's start with the left hand side, the day-night bar. So what this is doing is it's showing us exactly where we are in the course of a night. And of course the dark blue there is representing night, the kind of slightly lighter blue is twilight, the various twilights that we use, and then the light blue of course is daylight. And you can see here we've got different bars on it, and the first yellow bar here is just next, it's actually between the two green bars. So let's take a start from noon on the left hand side then. So there it is, local noon in Chile, just outside Santiago. Daylight, 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 and then we hit this first orange line. Now that orange line is denoting sunset, and when we put sunset in here, it's not kind of the local sunset behind the hills, it's when the sun drops below 0 degrees. So that's then. Then we know something starts an hour after that, which is the blue line. It's difficult to see actually in this view, but an hour after the sun sets, the domes open. Actually, I think there's something wrong there. But anyway, that's what's meant to happen. Then we've got two green lines here, and our yellow line, which is denoting the current time, is currently between the two green lines. And the two green lines are the start and end of what's called astronomical twilight. And it's really at the end of astronomical twilight. In fact, I'm not sure if that's not wrong either, actually. I'm going to check on this after the show, because I think we might have some terminology mixed up there. There's a great article actually in discussion boards about twilight that I wrote in there. But anyway, between the first green line is really denoting when missions start, but the second green line is denoting when twilight ends and we're basically in astronomical darkness. So yeah, actually that is correct. So astronomical twilight is in that first, usually it's around half an hour at both observatories. It does change slightly depending on what time of year it is. And this is where traditionally on Slooh you used to see what were called editor slots booked up in there, because it's really not a good time. Astronomical twilight is not a good time to be scheduling faint objects because the sky is still quite bright. And if you try and image a faint object during that period when the sky is still quite bright, you get lots more noise in the image, which means you have less signal, which means it's more difficult to find your faint object and discern your faint object. So anyway, after the green line, absolutely everything, but what we certainly recommend is in those periods, both in astronomical twilight at the start of the night and the end of the night, you can see at the other end of the night over to the right, it's exactly the same kind of principle. We recommend that you only schedule bright or brighter objects. And the kind of objects there, we mean any planet, of course, which is why you'll often see planets scheduled at the beginning and end of the night, but also globular star clusters. Globular star clusters are so bright that they're really not affected that much by capturing them when the sky background, when astronomical twilight is there. So anyway, there is our day and night, and then you can see you've finally got sun up over on the right as well. So I'm just going to go off actually and check another page a minute, because, do excuse me. So our first mission tonight was 0010. Yeah. So those entries are correct for that. Anyway, let's hop over to our day-night map. So this is showing us very clearly, actually, the whole globe spread open. You can see the right at the moment. So you've got Dave Larkin, Keith Smith, and other members down in Australia and New Zealand. It's their midday roughly at the moment, with the sun high overhead. The big dark blotch in the middle, well, that's nighttime. So any area that you see currently within that dark blotch, it's nighttime. You see the position of the moon. So if you were in East Africa, the moon's going to be directly overhead at the moment, or at least as high as it can be in the sky tonight. The first little red dot over there, that's Canary Islands. We'll take a quick look at the Canary Islands in a minute. So we're nearly halfway through the night in the Canary Islands. Local time there is 1:45, so 12:45 a.m. But then over here in South America, we can see the little red dot that denotes the Chile Observatory, and one can see it's just sneaked in. So it's gone through all of these other forms of twilight, which are these lighter bands. So things like nautical twilight, civil twilight, then you get astronomical twilight, and then you get darkness. And that's what the observatory is in at the moment. So we're going to hop through these panels because I don't think we've ever done this in any detail. So then we're over to the weather panel. Now, the first thing here is the forecast. Obviously really important for us if you're planning your missions later on this week, and we'll take a little look at the Canary Islands Observatory a little bit later, and you'll be pleased to see that we have clear. The word clear appears in the Canary Islands forecast. Now, you're not seeing things. Yeah, we've actually got some good weather. Anyway, so there we go. Sunday night, 4th March, 5th of March. Okay, yeah, because my clock's set to UTC. So Sunday evening, clear. That's great. Got a couple of days. So Tuesday, Wednesday, when we see chance of high humidity, that means there's a very good chance that we'll be closed. Slight chance of humidity, anybody's bet. Light clouds, we'd usually open under light clouds, sometimes even moderate clouds if we think they're going to dissipate and go. So anyway, a couple of days there where we might be closed in Chile, but we'll take a look a little bit later. But anyway, the other things that you can do on the weather tab are current weather conditions. So here we go, wind speed 0. We're very fortunate at our particular location there. The winds are very cyclical. Yeah, and if you look at the weathered graphs for the Chile Observatory, we land up with these high winds. You know, it's real kind of west coast, oceanic type cycles. Late afternoon we get the wind building, but then it drops, so that at night after sunset, the winds drop to nothing. Humidity, yeah, Still in summer there, 67. It is usually a lot higher there. We don't see the incredibly low humidity that we get in the Canary Islands Observatory, primarily because of its altitude. Take a look at its the local satellite view, so we can see here. You can always check the date, make sure it's current up in the top left hand side. We've got some other satellite views that are going to be coming up. Mission status, this is where you should come to have a look to check what happened last night. So every day this is updated. So this is the observatory status report for Saturday night. And you can see here we had light clouds and moonlight affected some missions, but the Chile 1 telescope was online. And we've also got a little note here that says moonlight creates a color hue across the images, and that's what you will see every now and again when the moon is up in Chile. Then it can cause a kind of green or blue hue over those images. But we can check now. So this is a live view of the all-sky camera. So what have we got here? We can see the constellation of Orion there, which means that's the dog star there, Sirius, burning bright directly overhead. What else can we recognize here? Is that the Southern Cross up the top, maybe? So anyway, we are adding a little later on this week a time lapse for the Chile All Sky camera, so you can check last night in a time lapse, so you can see when your missions were. And the time lapses are so good at showing you whether or not there's any light haze or any light cloud that you can't see in any particular image. We've got our dome cam, which does have the time lapse. Our dome cam is changing this week, so this is the kind of time lapse that you can expect to see. So this was yesterday. That's fairly short-lived, that one. But then we've also got our horizon cam as well, which is looking quite good. Got a bit of a light dome there from Santiago, the city, but that's nothing worry about. Anyway, let's hop over, because really what I was getting at was the Canary Islands telescopes were open earlier but have since closed. And how do you find out why they've closed? So let's go over, that's our day and night bar. So you can see here we're virtually in the middle of the night because the yellow bar is roughly in the middle. And you can see here as well, obviously, that Canary Islands is currently in winter. So the hours of darkness are longer than the hours of darkness in Chile's summer, which is why those two things change. And then we've got our day-night map, it's the same, but the weather here. So we've got for Sunday night clear. So you might be thinking, well, why aren't the domes open if it's clear? But there you can see we've got clear during the week. Let's have a look then at the current conditions. And there is the culprit, bang, in bright red figures. We've got very high wind gusts. In fact, they were over 25 miles per hour slightly earlier. Some comments, by the way, earlier on in the discussion boards about the units of measurement. We're looking at the potential of maybe giving users the opportunity to change things like temperature from Fahrenheit to centigrade, miles per hour to kilometers, and even UTC, which is the time standard used by astronomers around the world to coordinate all of their observations, but maybe even showing those in your own chosen time zone. So let's take a look at the satellite. So yeah, satellite is bearing out. So, and mission status last night, high winds and high humidity last night. The telescopes are offline due to high winds and high humidity. So hopefully those winds will drop a little bit later. But there we can see the moon's up down there. So let's have a look at the dome cam. And I don't know if you've used these yet, but the time lapses. Look at this. The camera's actually wobbling around. Look, there goes the moon setting. These are great, these time lapses, and we're going to have one for the all-sky camera and, in fact, the horizon cam as well very shortly. But you might see here examples of what we call an alpha alert, where these clouds, you can see the clouds just behind the bang. Look at that. That is an alpha alert in force. That is the entire observatory being engulfed in the cloud and precipitation. So that's why, 1 minute you can be looking at beautiful clear skies there, But the next minute, we're in total saturated conditions, and that's why sometimes we have to remain closed in those borderline conditions. But anyway, I just thought I'd show you that. But what's happening in the community this week? Because don't forget, we're going to be covering the telescopes when we are guaranteed that the Canary Islands telescopes are online as well, so we can contrast and look at the same object in different telescopes, so that we can see why they're best suited for various things. But look at this. These are the first things. Now, who's done this? This is Nicole B, and we'll come on to Nicole B in a minute, because she captured something for the first time this year that nobody else has managed to capture, which is quite cool. But what we want you to do, what we're hoping you're going to do, and it's what I do, in the observation log, this timeline that we've got, we want you to add your own interesting piece of information here, your own observation log. So tell us why this was special for you. And we can hop through. And there you go, Nicole B. I didn't realize you'd actually shared this, but this is our first Saturn image of the 2018 apparition of Saturn. An apparition is just a fancy word for viewing season, really. And I had spotted that Nicole had scheduled this for Chile last night. And actually, given that it's still quite low and really quite distant, that is a really cool image. I was expecting it. In fact, I warned people in the discussion boards that it would probably be really quite fuzzy. But anyway, thank you very much, Nicole B, for bringing our attention to that. And in fact, what we've done now is we have scheduled Saturn missions at the end of missions every night at Chile, so you can hop aboard those. So anyway, that was quite good. And there was this discussion over in the discussion boards about this, and here it is. Saturn Returns. There we go. So I was just looking at this, and just to tell everybody, bang, there it is. It's back. It's with us. And also, it brought up an interesting little subject that we've been talking about a lot here at Slooh, which is about trying to communicate the difference between apparent size and an object's true size. So an apparent size is the size an object appears in the telescope or through a pair of binoculars, whereas the object's real size is, if you were there at the object, how big is it? So physically, how big it is. And I did come across this interesting little graph here, which shows us kind of the changing apparent size of various objects, especially planets, because Jupiter is showing up beautifully at the moment, but that's because it's quite large. It's still not as large as it's going to be at opposition. And opposition is when a planet is at its closest to Earth. It's opposite the Sun from Earth's perspective. So when you're looking at Jupiter or Saturn on the night of opposition, think about wherever you're looking, the Sun is immediately behind you on the other side of Earth, drawing a straight line from the Sun through your head, well, actually through the center of the Earth, and then off to the planet in the distance. But I did share, I could not resist sharing this little snippet, which is quite amusing, where this chap is trying to explain the difference between the size of a toy cow and the size of a real cow outside, which is a long way away. But anyway, listen, thank you very much. Nicole shared her image of Saturn in here as well, which is really quite cool. And in fact, we might, let's do this. I am going to save Nicole's image to my machine, because we'll take a little look at that later on, maybe with some image processing, because it would build on what we got last week. Now, we've got Stefan. I think it's Stefan, or is it Stephen? Stephen, you need to write to me. I'll write to you actually, and I'll find out. I'm pretty sure you're a Stefan rather than a Stephen. But anyway, he always comes up, long-time member, always comes up with some great stuff about the visibility of objects and stuff like this. And look at this. This actually, thank you very much, Stefan, because this is something that I wanted to talk about. So Stefan's writing here, I'm looking forward to Saturn's opposition coming up in June. Saturn's brightness at opposition is currently at a 15-year high. Saturn's apparent ring tilt is also near a 15-year high at 97% of maximum. Now, you may know that most of the planets, in fact, are tilted. Their axis of rotation, in other words, how they spin, just like the Earth, is tilted. On Earth, it gives us a season. Actually, on all of the other planets, it gives us a season. And in Saturn's case, one of the interesting results of this is that as Saturn goes around the Sun, its tilt changes. So in other words, a Saturnian year is something like 29 Earth years. That's how long Saturn takes to orbit the Sun. And in that period of time, that relationship, or the face that Saturn is pointing towards us, changes. So at the moment, if we look at, if we go back to Nicole's image, we can see that Saturn's northern hemisphere is tilted towards us. I know it's the northern hemisphere because all Slooh images are north up. So anyway, I think that's correct. So we can see that its northern hemisphere is kind of in what you could call Saturn's summer, whereas its southern hemisphere is in its winter. In fact, it'll actually be in the shadow of a lot of those rings, or part of it will be anyway. And what Stefan has very kindly given us here is a diagram showing this apparent change in the tilt of Saturn from Earth's perspective. And you can see at the moment, not quite as good, I think, as last year was, which was almost fully open, 6 degrees. So it's not a huge amount of difference, but there's enough difference actually that last year, so in this one here, in the graphic that's labeled 2017, June 14, you can actually see something quite special happened last year. We could just see Saturn's outer rings beyond the sphere of Saturn itself, whereas this year it's actually back to just obscuring that outermost part of the rings. But we do get to see, of course, the southern hemisphere of Saturn through what's called the Cassini division. Now, Cassini was one of the guys who first observed Saturn. Another kind of 17th century thing, and it was 1617, I think. Gian Domenico Cassini. He discovered that Saturn's rings weren't solid. You know, before that, Galileo Galilei observed Saturn's rings in 1610, when actually they were on quite a sideways tilt. So, like we're seeing maybe in the top row. And Galileo's observations of that, when he saw it, he interpreted that as it being three objects. The planet in the middle, the main planet in the middle, but just like he'd seen with Jupiter, maybe moons on either side. But about 60 years later, Cassini, with a larger and better telescope, he was able to discern this dark ring, or what looked like a dark ring, and you can see it in these. So any of the ones where you can see the rings clearly because Saturn's pointing towards us, you can see there's that dark division, and that's what it is. It's an area in the rings which is basically empty. It doesn't have very much in it, and it's now named the Cassini division in his honor. And I think he drew that. I think it was 1675 or 76, something like that. But if we go back to Nicole's image, we can just about make out a darker patch. But as Saturn gets larger and larger, as its apparent size changes, as it gets brighter, as it and Earth get closer and closer as actually the Earth orbits the Sun. We get closer to Saturn. Its apparent size will increase and it will become a lot easier to observe and capture the Cassini division. So anyway, thank you. That was a bit of a digression. I wasn't planning to go into all of that detail, but Stefan, thank you very much for that diagram. That really is quite good. Let's take another look, see what else is happening over here in the community. You see the main threads. Oh yeah, we missed this little asteroid that zipped past Earth, and I think it was 65,000 miles away. I think I put a bit of info in here. Yeah, 69,000 miles. I mean, that's darn close. Only a tiny little rock though, tiny little space rock. About 12 meters across, something like that, 40 feet, something like that. So anyway, unfortunately, we didn't capture that one that night. What else have we got? What's happening? Spectrometry. Okay, a little discussion going on there. Saturn Returns was the big news of the week. An asteroid. Post a template, don't forget. What's David H saying about that? You have got to join in if you haven't captured it. If you haven't watched one of the shows or caught up with the Messier Marathon, which is going to be on the 17th, then make sure you catch up with the shows and exactly what we're going to be doing. David H is just saying he was thinking of another format. So what we've got this really great. Let me open it up for you because I think I've got it here. So we've got this great template which Slooh member Andrew Dumbleton allowed me to update and adapt from one that he had done, and we're going to be using this for our Messier Marathon. And in fact, what I'm going to show you a little bit later is one method that I found for anybody who doesn't have Photoshop or lots of image processing software and stuff like that. I think I've come up with a pretty neat way of being able to do that. So that's going to be quite cool. But anyway, David's just saying that he's got another idea, maybe a word format one. That would be very easy to do as well. So we'll make that all available for next week's show. What else? Anything else going on? It's been a bit of a quiet week, hasn't it? But question there for Paige, Dr. Paige Godfrey. If you are missing her Intro to Astronomy courses, don't. You should catch up with all of them over in live casts. Image boxes, another close apparition. Okay, not a lot else going on there. So, Return of Saturn, we've done that. How to check observatory conditions, taking you on that. Now, some of you have been asking for a little bit more image processing. Now, as you may know, I am in the process of developing our own courses, and sorry, I'm just loading up a couple of other things at the moment. I'm developing our full image processing courses where I'm hoping to get the help of people like Dave Larkin. I know Dave's been working on quite a few tutorials lately, but I came across something quite interesting this week, and let's get rid of that one. And it's this little utility here. This is online image processing. So we maybe will use this as the base level of image processing. So this is all online. Nothing's running on my particular machine. And I'm just going to add an image here. And I've got a great Jupiter image from last night. It's quite cool, isn't it? And it's got little zoom tools on it and stuff like that. It's now, as you saw last week, this is a pretty cool image to start off with, but what this online utility gives you is a whole stack of image processing options. And the one that we talked about last week was sharpening planetary images. And we were saying there, if you've got a good image to start off with, and this is one, you can sharpen quite a lot. So it's got this little sharpness slider that you can put along, and hopefully you can see how much more detail it's pulled out in some of these regions. Now that's quite heavy I've gone to. We can slip between the original and the one that we've done. So it's a shame that loses the... oh, right, okay, hold on a sec, because it's got a compare thing here. I haven't spotted that when I did it. It's not, that was not working. So we'll take a look at that. But anyway, there are some pretty interesting options in here. And in fact, the one that I wanted to show you was something that we're going to do over the next couple of weeks as part of the Practical Astronomy series. But we're going to kind of jump on to a little bit of image processing at the same time. And I just wanted to play amongst yourselves for a bit, because I'm just off going to get an image from last night, because I wanted to show you something here, because it's one of the most basic parts of image processing that you can get. It's one of the most important steps in astro processing. Just trying to find a good donor image from Chile last night. Sure there will be one. My machine's working overtime like it normally is, streaming a live show. Cool. There's never an emission nebulae around when you want one. So I know what we'll do. Let's hop over to the home page, because very kindly Nicole B shared one. Here we go. The Lagoon Nebula. This is going to be a perfect image to use in this example. So there it is. Save image as. I'm going to save it to my desktop. We're going to go over to this image processing software. In fact, I'm just going to clear this. Yeah, we'll leave that page. Thank you very much. Because it's got a really cool routine that we can use in here. So we're just going to open up the M8 image that we've just... So this is Nicole's image from Chile last night. And this is something that we're going to cover maybe even as early as next week. We're going to cover two basics of image processing. One is sharpening for your planetary and lunar images, but then we're going to cover curves or stretching. This is what it's called. And as I say, this is such an important aspect of image processing, and it's something that you can look at before we do that show. So you can just try it out yourself, and you'll see a very typical curve. So what this is showing here is this curve, which is actually a straight line, is showing basically it represents all of the pixels on this image, and the left-hand bar is what's displayed, and the bottom is what's actually there. And at the moment it's a one-to-one mapping. But look what happens. I click on this curve and it automatically puts a point in there, and I start building up this kind of curve. Now what this is doing is it's saying use more of your range that you can show me for this number of pixels. It's mapping pixels and it's pulling out fainter ones. So what you can see here is in the outer arms of the nebulae, when it's straightforward, when the curve is straight, the original image in other words, you can't see much. But then look what happens. We're pulling out, making brighter the fainter regions of the nebula. But look as well what's going on here. The very center of the nebula is so bright that by doing what we've just done, it's made it saturated. Saturated is when it goes pure white. But in our curves, we can prevent that from happening. This basically up the top, this straight line at the top, is what's called clipping. And that's what we've done to our image. We've said that all pixels with a brightness value of in that range, set them to absolute white. Well, we don't want them white. So what we can do add another point in our curve so that there's no clipping going on there. And you can start messing around. You can start you can actually even make this curve even steeper. And don't forget, exactly the same principle exists as the sharpening. The better the original image, the more processing you can carry out. So that's just a very rough. All right, that's good. There you go. So the little compare button down the bottom on this tool called Photor, Fotor.com, allows you to flick on and off. Look at the other nebulosity that we're pulling out. Look at this area of nebulosity at the top. In the original image, it doesn't show up at all. In this one, just look at the extra structure. And this is from me not taking any care over how I've produced that curve. But that is the kind of curve that you want to be practicing with. This is quite an extreme one, you know, so you might want a slightly calmer curve there. But what you must avoid at all costs is that clipping, because when you know you're clipping, you're losing data. All right, so that's quite cool, isn't it? And I thought this was really good. Maybe for us to do our online, to maybe look over just some of these image processing basics. And you can see here that we've actually introduced quite a lot of noise because we've been a bit aggressive on applying curves there. But you can see immediately, and don't forget, we're working on the PNG here. We're working on the image that's in my pics, not the FITS data and all the complexity. We're working on an already color processed object. So what we're doing here is we're not creating, we can't suddenly create new detail in this image. It's just this image contains this data, and all we're doing is we're changing the way that data is displayed. And we're really balancing, we're changing the balance of this image so that all of the fainter areas are kind of given more space to be displayed. And that's what curves and levels are. So we're going to take a good look at that. But anyway, I know a lot of you have asked maybe for more image processing in these shows. I just wanted to show you one last little bit on this, actually. Make sure that I can get this up on my screen. Come along. There we go. Transition to that. Switch this one off. Bear with me, folks. Right, here we go. We are in our image processing software, and I just wanted to do two things, because one of these we did last week, and the other one we've done tonight. So here's the Jupiter image that we used in that online tool a little earlier on. And as I say, this is a pretty cool image anyway. This is as it came from the telescope last night. But instead of using the sharpening tool on there, what we really want to do with this planetary image is use the unsharp mask. So I'll tell you what we'll do. We'll only apply this unsharp mask so we can really see the difference it makes to 1/2 of the planet. So I've just defined an area there. So anything that I do on this image is only going to take place in that part of the image. I'm going to use my unsharp mask. And it's set on 50 at the moment. We can be more aggressive with this, don't forget, because it's a good image to start off with. Let's go 100. Wow, look at that. Look at the difference between the two. Now, we're introducing a little bit of noise there, but I think we could still be a little more aggressive. Let's go to 125. Right, that's starting to introduce some artifacts. You can see, you know, some of those pixels almost changing color, almost becoming iridescent. Let's show you the extremes example of it. If you overdo sharpening, look at that. That is totally false, that image. It's pulling out details and information which is not there. It's also, you know, increasing the noise dramatically. So always kind of be a bit conservative. So 150, 125, I think, is where my eye would go on that. And you can see just how much difference it makes. So somebody also made the comment during the week, because some of Keith Smith's images that he puts up, you can see the moon far better on them. Well, all Keith does is a little bit of unsharp, and you can see suddenly 2 moons here have popped out. And actually, you can be quite aggressive with the moons. I would never normally go that aggressive, but you can go quite aggressive without kind of distorting, because they're so small anyway. But what I wanted to show you, so that was just another example of that, but what I wanted to show you is Nicole B's Saturn image. So this is the first Slooh image of the Saturn 2018 apparition. Now, you can see already that this image is noisy, it's blurry. Conditions were good last night. This was taken only minutes after the Jupiter mission that we just saw was taken. So don't forget, you can see these minute-to-minute distortions in the atmosphere. But the point I'm making here, in fact, this has already been kind of processed once already, but the point I'm making here is, in these early days of Saturn's return, don't be too disappointed with your images, because this is pretty darn good, because Saturn is so small at the moment. So if we try and do the kind of sharpening that we were just doing on Jupiter, just start looking at, so let's go 125 as we did, just look at how much worse that makes this image. It introduces loads more noise. So one interesting thing actually that you can do, if you've got images from the same telescope, is you can compare their apparent size. And we were talking about apparent size earlier. So let's take this Jupiter image and let's paste it into our Saturn image. And there you can see quite clearly the apparent size at the moment, because Jupiter is a lot closer to its opposition when it's closest to Earth than Saturn is. And there was a little discussion about this in the discussion boards about this apparent size. So let's just hop over to our favorite program, the Sky, and we can see this is how I got the figures for that post. Let's turn off this database of the Messier objects that we've got. I am so excited about the Messier Marathon this year. I think it's going to be the best one we've ever done. We've got more telescopes to use, stuff like that. Anyway, listen, in the Sky or your planetarium software, all you need to do is search or click on your object. And you should see somewhere an entry for it, which says, be down here, apparent angular diameter. Now, angles in the sky are measured in degrees, minutes, and seconds. So you can see here the apparent angular diameter of Saturn at the moment is 0 degrees, 0 minutes, 16 seconds, 16 arc seconds, that is, because it's actually an angular measurement. Now, what we saw earlier from Stefan was Saturn's opposition is going to be in June. So if we change the month, we'll just watch that apparent angular dimension change. So it's 16 arc seconds this week. Next month, it goes up to 17 arc seconds. The following month, 18 arc seconds. And then, yeah, it peaks around 18 arc seconds. Let's do the same thing for Jupiter since the beginning of this year. So, in fact, what did we say Saturn was now? 16 arc seconds. So let's hop back to the beginning of the year. Let's have a look at Jupiter. And we can see here already at the beginning of the year, it was 33 arc seconds. Bring that forward to tonight, and it's 40 arc seconds. So it's already, 3 times, nearly 3 times the apparent size of Saturn. And then hopping up to opposition, 45 arc seconds, and then we're after opposition. So our little image here, what you could do is you could measure in the number of pixels across here. So you could do a little box or have another way of measuring how many pixels across this is. So there we go. So see in the bottom, it's 77 pixels wide. We know what's called our image scale for certain telescope. And we'll get into this in the image processing course. But each telescope, we know that each pixel covers a certain amount of sky. It's usually somewhere in the region of 0.7 to maybe 3 arc seconds per pixel. So actually here you could do the calculation, and you could actually calculate the image scale of the telescope that took this particular image. But anyway, I thought that might just be interesting, just take a very quick look at there. And I think that was about it for tonight. What else was I going to take a look at? Yeah, so we are going to we'll start introducing, just pick off some of these early image processing fundamentals. So sharpening on lunar, solar, and planetary images from Slooh. And then we'll look at maybe picking up some of these curves. So that was in this program over here. So this website helps if I turn one thing off before I do the other. So in here, this was our curves, and you can also, we can reset this back to our basic image. In here, basically you can change the contrast and brightness as well. This does something slightly different, but this is a linear change over our image. So what you can see here is it's changing every single pixel. It's just making every single pixel in the image brighter. But what that means is that the sky background is coming out as well. It's not black anymore. And one of the fundamentals in astro image processing is that you always want to keep the sky dark. All right, so you can maybe do a mixture of this kind of linear editing, pulling stuff out, but then we are going to be looking at these lovely, there was go to curves, put a few points in, stick one in there, another one in there, maybe make that less aggressive at the top. And in fact, you can see that that little bit of lightning that we did at the beginning was just too much for this particular processor. So I guess, can we reset that? Doesn't look like it gives us a reset on that. So yeah, I didn't like that. But anyway, you saw the principle slightly earlier on. So let's go back to basic. It's annoying me now. It looks nasty. Anyway, that's a pretty cool little program that we are going to be able to use because you can follow along online during the show. We can all download the same image, so keep an eye open in the discussion boards for this particular live cast series. So if you hop over, this is actually called a course. And if you go over to Practical Astronomy with Paul Cox, what I'll do in here is whenever we're going to do a little bit of image processing, I'll upload some example images. Of course, you can use your own images if you want, but if you wanted to follow along and all use the same images, then that might be quite a good idea. So anyway, that probably rounds it up for tonight. Don't forget, if you do have questions for me, please post them to the discussion boards and I'll come on to any of those. In fact, we have got a couple of minutes left, and there was a question a couple of weeks ago about setting up a mosaic. Now, let's go to the discussion boards, click on there, and we'll do a search. And I'm going to do a search for mosaic. So we've got a couple here, faint nebulae. Oh, that was the other thing I meant to talk about. Oh, gotta remind you of that. Yes, please. This is a really great opportunity that we've got coming up in a couple of weeks' time. Close a couple of windows down. Come on, let's get to one of the really cool mosaics. Oh, well, this is an absolute classic. Triangulum, a whole constellation done as a mosaic. So a mosaic is basically pulling together lots of images, can be hundreds of images sometimes. This one is 132 panels that Peter Eilers has pulled together to show a far larger area of sky. So he's used the Canary 3 telescope, deep sky telescope, which has already got a large field of view on it. And he's set up this mosaic and taken lots of different images in a patchwork across this area of the sky. This is the Triangulum galaxy on the right-hand side, and if you've seen that through the scopes, that normally fills the field of view of most of the telescopes at Slooh. So you can see just how big this gets. But there's one tiny little thing that I'm going to introduce you to this week, and we'll actually, you couldn't see anything that I was talking about then. Oh, Cox, I've got to get my act into gear so you can see this stuff. We'll go back to this image because it is so cool. So this is Peter Eilis's mosaic of the constellation of Triangulum, and there on the right hand side is a Triangulum galaxy that I was pointing out. But I just wanted to show you the very first stage of setting up a mosaic. And there's a couple of tools that that Dave Larkin has shared in the discussion boards, but I just wanted to show you one here. Now let's take an example of, in fact, let's take this example of Mars. I'm going to run out of time here, folks, but we're going to zoom out, zoom out, zoom out. 1 degree. Get us north up. Zoom out even more. And the Sky and several programs have this wonderful utility that will automatically create a mosaic for you. So I'm just centered. This is talking about this great event that we've got coming up on the 17th, 18th, and 19th. And what we'll do is we'll use this as an example of creating a mosaic. So we'll do some image processing together on this, because what you can see here is down here is the Lagoon Nebula, up here is the Trifid Nebula, but in the middle is Mars. And look what happens over 3 days. So starts off there in the west, hops over. By the time we're on the 19th and 20th, it's going between those two. But you can see only on one night can we really get the 3 objects, but we can only get the edges of the 3 objects in the field of view. So I'm going to hop onto this really quick. There's a tool in here, which is a mosaic tool. And what this enables you can do, you can't see the little box I'm sharing with this, but basically what it's doing is it's enabling us to select a particular telescope's field of view, in this case Canary 3, and what it's done is it's created 3 panels to cover those 3 objects. So we are going to do a mosaic time-lapse animation of Mars passing between the Lagoon and Trifid Nebula. So make sure that you take a look over in the discussion boards, because there is that post over there. Let's take a quick look. It's not that one. Let's take a quick look before I get cut off. I've already been cut off once tonight. Here we go. This is it. So have a look under discussion, image processing method, and keep an eye open for Mars, Trifid, and Lagoon Nebula rendezvous. And this is telling you the coordinates if you want to set up your own mosaic missions for that. But anyway, listen, we got no Helen Avery tonight with Constellation Stories, but she's going to be back next week. Got Paige Godfrey is going to be joining us for her intro to astronomy on Wednesday, where she's going to be talking about gravitational lensing. I'm going to be back next week for our countdown to the Messier Marathon, plus another edition of Practical Astronomy. Please tell me what you would like me to cover in this Practical Astronomy series. It's designed around how to use Slooh, how to use the telescopes, how to book your missions, how do you all use planetarium tools or processing tools or anything else you might think of that you would like me to cover. And we'll cover them on these Sunday night slots. So anyway, listen, it's all for me for tonight. Let's take one last quick look, see what's going on over at Chile. What have we got coming up here? Right, NGC 2867. Oh, no, it's just... Oh, look at that. We were talking about this object earlier on tonight, it's Messier 1, the Crab Nebula supernova remnant. Now, how fitting is that we should finish off our evening of live cast by watching this Messier 1. Great object. I'm going to snap that before it goes to color because it's got some quite cool details in. Probably ultra wide field, it'll look a bit small. Yeah, it's a bit small in there, but actually it adds a bit more context. Snap one of those as well. Anyway, that's it from me tonight, Paul Cox. I'll see you next week. And don't miss Paige Godfrey, Dr. Paige Godfrey show on Wednesday, her intro to astronomy course, and then Helen Avery will be back next weekend as well. So see you soon. See you next time. Bye.